Please put your hands together for Mr. Ron Stewart.
Thank you very much. Thanks for having me this morning. A little bit about me. My background, just to give you an idea where I come from, and speaking about Industry 4.0, the military had nothing to do with it, or did it. My military career actually started back in the 1980s, and as an officer I was on active duty, and I actually was on the ARPANET, predecessor to the internet, and I saw a little green box out on a field that had, when they pushed a button, little numbers popped up, latitude, longitude, satellites, GPS, and now we've got that kind of stuff on our phones. So I guess even in the Army back in the 80s, I saw some of the cool technology that was coming before it got here. I did work at Rockwell for a while, and I cut my teeth on PLCs. So controllers from the 1970s and 1980s, old PLCs, PLC2s, HMI software, and I worked in the ERP space for a consulting firm. And I went back to Rockwell and was part of their Connected Enterprise, Connected Consulting Services team, and now I'm with SIP. So here's what I'm going to talk about for the next half an hour. I'm going to talk a little bit about just setting the foundation of Industry 4.0. What does it mean? Why should you care? What's the value? We'll talk about data and connectivity, and I've got a real-world use case that I want to talk about in terms of when I say make it real. What does it look like when we say make it real? So first off, in our worlds, we've all lived through some digital transformation. Again, we're all walking around with these things in our pocket, and for those of us with a little less hair on top, we remember landlines, and maybe we still have landlines in our house. But today we're walking around changing our thermostat remotely from our phones. Well, my favorite story is as a runner, I used to go out when I was a teenager and run and come back and just log it in a notebook. If I wanted to know how far I went, I actually had to take the car or my bicycle, right? And drive the route. You guys are nodding your heads. Oh, I ran 4 miles today. Well, what do we do today? We take our GPS watch and we hit the button and we go for our run and we come back and we hit the button and all the data goes up to the cloud. And I'm kind of geeky about that stuff. I like to take a look at where I went and how fast I went and my cadence and my oxygen, my VO2 max, and all the heart rate type information. And it even has a preventative maintenance feature in the software. And that is specifically that it tracks the activities against my shoes. So I'm one of those guys that in the garage I've got multiple pairs of running shoes, which drives my wife crazy. And what happens is the app alerts me when my shoes get to a certain threshold, which basically for me is preventative maintenance. If I run too many miles, about 400 plus, in a pair of shoes, those shoes start to wear out and I start to feel Achilles tendonitis type problems. So at about 350 miles, my app gives me the little warning and says, hey, it's time to maybe go buy a new pair of shoes. So how is that not any different, per se, than what we're trying to do out in our production operations? We want that information because we need to be a little bit geeky about what's going on out on the factory floor with our machines and devices. But a lot of times in today's world, we don't have visibility to that information. And that's where Industry 4.0 comes into play. So I don't know about you, but when I was a youngster and I was in school, I remember in history class they talked about the Industrial Revolution. And maybe it's just because I'm older now, but now there's 4 of them, and I don't know how that happened because I'm not old enough to remember the first Industrial Revolution. But I did, however, experience Industry 3.0, which was where we saw PLCs, robotics, and other types of computerization come into factories. And what Industry 4.0 did for us was it did automate certain processes, but it left us with just that. Islands of stranded automation with islands of manual processes, and then likewise, islands of stranded data. So we still see in a lot of plants today, people running around with clipboards, looking at screens where automation is, writing down the numbers off of those screens, and then taking them back into an office and punching it into a spreadsheet and then emailing it to somebody. Is that really, how we want to run our factories today? And when the bosses up high say, What's our uptime? What's our OEE? What's our capacity? We've got to run back and do all kinds of calculations in those spreadsheets, and it's not very fast, and it's not fast enough for today's environment. Thus, Industry 4.0. So I want to talk a little bit about terminology when it comes to Industry 4.0, and I've got a lot of words up on the slide, so I'm going to simplify this for you. I like to bring this up just to take some of the terms that we hear about out in the world and kind of bring them to focus in this conversation. Digital manufacturing is really just Industry 3.0. It's just the computerization or the automation that we've brought into the factories. And when we talk about the Internet of Things, we're talking about things like the cell phone, my watch, the thermostat on the wall at home. Those are things that are on the Internet. If you add the I in front of that, we're talking about industrial Internet of Things, or say it backwards, things that are on the Internet or things that are on the network that are industrial. So IIoT is really a subset of IoT. Industry 4.0 is actually a term that came from Germany, and it's actually been around for a while. It's been around for about 8 years. And in the United States, we talk more about smart manufacturing and smart factories, and smart factories are really just facilities, physical facilities that have implemented some of those Industry 4.0 concepts. And smart manufacturing is an umbrella term mostly used in the United States. Around the world, you'll still see other countries talk about Industry 4.0, and in Germany, if you go to the Hanover Fair, they still talk about Industry 4.0, and you'll see I40 up on a lot of their placards. But here in the States, we seem to use the term smart. Smart this, smart that, smart manufacturing. And smart manufacturing in the United States is really to be a more broad term rather than just Industry 4.0, where we're not talking about just the production area, but the entire supply chain. And when you think about it, there's all kinds of data that flows through the supply chain. Everything from products that we create, item numbers, product specs, what are the raw materials, all that data is sitting in some sort of an enterprise level system. And then we create more data in the manufacturing box that you see up there. And that's really the Industry 4.0 part of this. It's the data that's out in the production area. But data flows through the supply chain. So we need to know the specs and how to configure machines to build the products from the left to the right. And then as the product leaves manufacturing and goes into our warehouses and distribution centers, we need to know where that finished good is. So now we've got a finished goods item number, and we need to know its location and the quantity. And when you get out to the right-hand side, there's data about the consumers. Who's buying our product, at what price, from what segment of the industry and so forth. So there's a lot of data that flows through the supply chain. And when they talk about smart manufacturing, they're talking about the entire supply chain. So why do I care? What's the value in this for me? And I boiled this slide down to just these basic bullets, because at the end of the day, when I talk to customers about Industry 4.0, it's all fine and well that there's great technology, but why do I want to put that in my factory? You're asking me to spend money on your products as a vendor of some of these bright, shiny objects, but why? What value do I get out of it? And it really comes down to productivity, compliance, and reliability and preventive maintenance kind of go together, the all-time favorite. What we're looking for in those last bullets is how do we turn this into more of a condition-based monitoring of our assets versus time-based. So I don't want to go out every so many weeks and do maintenance on a machine and have it go down in between when we're supposed to do that maintenance. I would really like to collect data about that machine so that I can prevent the machine from failing in the first place. So put it into numbers. There was a survey, there's a lot of surveys that have been done, but this particular one I pulled out at the end of the day, and you don't even have to focus on the numbers. That 4.1 could be 2.3 for one company and 6.7 for another company. It's really not the number that I'm interested in, but the survey came down to two primary factors for why people are interested in Industry 4.0 type projects. They're either trying to reduce cost, right, competitiveness, margins, what their competitors doing, or they've got growth plans. And the question is, how do I change what I'm doing in my production operations so that I can increase capacity or make sure that the uptime is where it needs to be so that I can support those revenue and growth goals that we have? Third bullet is something of really primary interest to me. Our company, SICK, is a German-based company. And the Germans are pretty patient. When they say they've got a 5-year strategy, they've got 5 years that they're looking at, right? but not here in the United States. Customers that I deal with in the United States, these companies are much more near term. I was going to say impatient, but I'll be polite. Much more near term. So what happens is, in this last bullet, is most companies want to see projects that produce some sort of return, some sort of value in the next couple of years, or they're not interested because things are moving that fast. Example, customer that I'm working with currently has a list of projects, and they're coming from the plants all over the country. And I sat down with him just a couple of weeks ago, and he had some of the projects where the value had been calculated to be a return in 18 months. And the plants were debating with this gentleman why they were being pushed off to 2021. And he said, the reason is I've got so many other projects with value where the return is going to show up in 12 months. Your 18-month ROI project got pushed to the bottom of the list. So my experience has been, it used to be that we could do projects and it could be 5 years payback. And now what we're basically saying is the payback's got to be much, much quicker. So that will impact what kind of solutions you choose, and I'll talk about that in a couple more slides. A lot of words up here, but the same company that did that survey basically recognizes that Industry 4.0 is not a bright, shiny object. It's not a box that you plug into and poof, you've got Industry 4.0. It's really the assembling of all these advanced technologies across your production operations. And the customers that they surveyed recognize that they need to get on board. And if you look at the second to last bullet, 88% of the respondents said, yep, I understand that if I don't get on this Industry 4.0 train, we're going to fall behind and our competitors are going to pass us up. But only 12% of those same people are actually doing something about it, which begs the question, if you know you've got to do something with this, why aren't you moving? 3 big companies actually went after that very question. So McKinsey, Gartner, and the Mechanical Engineering Association went after that exact question and said, why aren't you moving forward? What's keeping you from moving forward? And the 4 top answers came back the same in these 3 surveys. Number 1, they're struggling with the ROI. They're struggling to figure out, how do I look at what my business strategy is and tie that out to a value stream, and then tie that out to an actual project and put dollar signs to it. Because I have to take this project to my boss and I have to get somebody to sign a check. So they struggle with business justification. In some companies, they lack expertise. So I work with some firms that have entire Industry 4.0 corporate level teams in place. Most companies don't have the resources to do that. And they're very busy with their day jobs. So they struggle with finding people that kind of put the pieces together. The third one is just understanding. So a lot of smaller and mid-sized companies, again, they're so busy just keeping the wheels on the train that they really don't have time to go out and research this stuff. And data security is always something that everybody's concerned about, because at the foundation of Industry 4.0 is data and connectivity. And when we start talking about connecting devices and moving data, one of the first questions that comes up is, how do I make sure that my data isn't going to fall into the wrong hands? I need to make sure that it's secure. So those are the 4 primary things that we need to talk about when we sit down and talk about Industry 4.0, because we need to be able to resolve those questions. And at the end of the day, at the bottom there, what happens with most companies that can't fund an entire Industry 4.0 team is you're looking for an ecosphere of partners that can help you with this. So, Industry 4.0, it's all about data. At the end of the day, we've got islands of stranded information out on our factory floors. And that includes the manual operations, because oftentimes there is some sort of automation included that is working in a collaborative environment with humans, and the data that's being generated there may be collected on a piece of paper, maybe it's making its way into a spreadsheet, but at the end of the day, there's a lot of stranded information out on the factory floor. To collect that information and move it to the right level, you've got to have connectivity. And this then takes us into conversations and projects where you've got the whole conflict between OT and IT, where IT people don't want you moving or connecting things to servers in their space, but you've got data down here that the business people want. One of the things on this slide that I like to point out is, in the old days, when you go back to Industry 3.0, we talked about controls networks. And once the controls engineers had the control networks up and running, it was, don't touch my PLC. Don't mess with my controls network, because that has an impact on timing and how things are, the logic is run. The red lines represent a controls network. The green lines on this slide simply open the conversation to let you know that in today's world, with the advanced technology we have, there are sensors out there that can connect directly to Ethernet IP, and you can have data-specific networks that carry the data and do not impact your controls network. And that can go to servers on-premise or to the cloud. It's very, very flexible these days. So I joined SICK about a year ago. And one of the things that I really liked about this company was their focus on devices at the edge. And I was really into the Industry 4.0 message. And when I was working with our parent company in Germany, and I was collecting information from them and learning about SICK, this particular slide really stuck with me. So people say, Ron, where does SICK fit in this world of industrial automation and Industry 4.0? And I love that tagline at the top. Our sensors and our company, we are the suppliers of information for Industry 4.0. So in a sense, we understand that we're not everything in the whole big picture, but we do have an expertise, and we can collect and harvest that data that's out in your plants and move it where it needs to be. So data, big data. This was a topic that comes up a lot. And I worked with a data scientist once who used to get really annoyed when people would use the phrase big data. So I finally said, please explain to me what big data is to you as a data scientist, so that when I talk about it, I don't misuse the phrase. Well, big data, he said, is really 3 V's. And the first V is volume. It's just the sheer amount of information that we can collect and store today and look at. And if you think about technology, go back 10 or 20 years, computers and servers and a database that was big enough to store the data, it was pretty expensive, right? And you had to work with your IT folks, and they didn't want to spend money on storing all that data. But today's technology has become much cheaper. Data storage is easier. We have the cloud as an option. So the sheer amount of data that we can collect is a big deal. And then the type of information. It used to be that we were collecting binary on, off, maybe some numbers, parts counts, and things like that. And today we can collect pictures and videos, barcodes. Things are running down a conveyor, and we can take snapshot pictures, and that stuff can be stored for retrieval later. So the type of data is different than it used to be. And just the sheer velocity, the speed at which things can be collected. Now, I want to stop at this point for just a second and say, I actually see 2 camps out there. There is the camp that says, just collect all of the data, move it up to an advanced analytics package, store all that data, and we'll just use the advanced analytics to figure out what's going on. And at the end of the day, you're trying to get visibility to data so that you can make decisions and take actions. And I break up what do we do with the data into these 3 categories. It's either real-time diagnostic, I just need visibility. I want to store the data, and I want to do some trending analysis and predict where it may go into the future. Or I may need to do some prescriptive analysis because I want to know what to do about it. And I take these 3 terms and I put them up this way. So from a diagnostic perspective, we're looking at what is now, what's happening today. Most of the customers I deal with today are just looking for diagnostic visibility of information. I just need to see, is my machine running or not? And then there may be some health indicators that I need to collect: temperature, vibration, RPMs. I may need part count. And then the next level is collect data, store it, and do some predictive analysis so that we can determine when something may be heading off track. The prescriptive analysis can get a little expensive. Oftentimes, customers will say, I just need the information, and then as a human, I will decide what to do with that data in terms of the actions to take. But there are prescriptive advanced analytics software solutions that are out there if you're looking for something to automatically determine what to do and send it back into your control system. So back in the 70s and 80s, there was a pretty well understood controls architecture, and it was referred to in the 80s as the Purdue Model, because Purdue University and some manufacturing associations got together and they basically said a basic controls architecture and industrial automation looks something like this. And they gave the different levels, numbers, and said, here's the stuff at the control level. Well, I've created a RON version of that old Purdue model. And the RON version are these layers of automation where I've taken Industry 4.0 and I've added this into this picture. At the edge, if you look at boxes 1 and 2, in box 1 you have all kinds of PLCs, machines, sensors that are generating all kinds of data. In box number 2, we also have automation, so think robotics, AGCs, vision systems, any type of a system that is helping to automate a process. Boxes 1 and 2 are creating all kinds of data. And the question is, can you see what's going on? And do you have the information you need to be able to make the decisions at the management level and above? Box number 6. So there's all this data down here in boxes 1 and 2, but how do I get that data out of those machines? And what I have found is that in a lot of cases we've got these islands of automation and customers are struggling with their local integrators or with their own engineering people to figure out how to connect to those machines, pull the data out, and move it. So what you need to look for then are companies that have services that provide data integration. And at SICK, we happen to have an engineering services team that knows PLCs, sensors, relays. We can take your business objectives, convert those into what the value stream is, and figure out in box number 1 where that data resides, and whether it's in a PLC or a sensor, or it's not being generated, and you need to create that data, put sensors on it or pick it up off of a relay, and move that data into boxes 3 and 4. Box 3 is, think of an MES type solution, or any type of visibility dashboards that you might have in your production operations. And box 4 is more in the enterprise level, so your ERP type systems and enterprise software solutions at that layer. But to move that data, on a previous slide I said connectivity is critical, and therefore you need box number 5. You've got to have some sort of OT, IT connection at the machine level, some sort of a drop to move that through a switch and through all the firewalls and gateways to the servers in the enterprise level. If you put all of this together, at the end of the day, you can move the data where people need to see it. So, right data to the right people at the right time. So here's an example. We had a customer that has globally about 115 plants. And they are all over the map in terms of whether they're very automated or not very automated, very connected or not very connected, a variety. So we picked a particular plant that was very not connected. There were islands of automation, islands of manual processes, nothing was connected, and they basically said, we need you to light up our assets because we don't know standing here if those machines are running or not running. We don't know anything about the health of those machines. We don't even know what the part count is coming off of those machines. We don't know how many parts went into the bin or into the bucket today. So they said, we just want some basic visibility, diagnostic data about what's happening in our plant today. So we sat down and we looked at all of the products that they make in that particular facilities, and we identified 3 particular value streams that were important to them. 3 products of specific importance where they see growth potential in the market and they want to focus on those particular products. Then we went down to the next layer and said, what are the machines that are making those products? Where's the automation? Do they have controllers? Do they have sensors? Do they need to be sensorized? And we did all of that assessment, and then we provided them with a proposal that basically said, here's what the cost would be to light up so that you can see what's going on with these machines. And here's the value that it will provide at the end, and we put an ROI statement together with them. So you'll see those 3 different products and the machines behind them, and it was just to promote basic machine visibility and part count. We were moving the data from the machines. In some cases, there were already PLCs in place. In other cases, we needed to add a PLC. In some cases, it was just picking up data off of a relay that was already there, or an injection molding machine that had its own controller, right, So the data was already there, but they just didn't know how to pull the data out. So we sensorized those machines, picked up the data that was coming out of the PLCs, pulled all that data into a TDC, what we call a telematic data collector, so a device where we can collect data from multiple kinds of devices. And then that particular data collector has logic capabilities where we can actually prepare the data. Again, back to my statement about purposeful data versus big data. So the TDC then had logic that said, I want to know this, this, and this. We collected the data, we prepared it and filtered it, and then moved that data up and dropped it in a Kepler server. And in that Kepler server on-prem, they now have other advanced software solutions that they had already invested in, but those software solutions were starving for information. They didn't have the data that they needed. Now that we've moved that data to those Kepler servers, those software solutions can now pull out the data, and we've got a nice data lake, if you will, for them to pull the data out. And there was a project to put a data dictionary together so that plant to plant to plant, the Kepler server has the same data with the same object name, same tag names, and things like that. So, to summarize, when we're talking about Industry 4.0, it's really all about the data. And at the end of the day, it needs to start with an understanding and an assessment of what it is your company is trying to achieve, and aligning those business strategies with the value streams that we can then turn into to support those value streams. You need to collect this information from these machines, put it here, visualize it, and take these actions. We then confirm the value with use cases, prioritize and make a roadmap, and then begin the implementation. And the two slides before that are an example of following that journey and implementing in one plant as a pilot to show what can be done, and then repeat that 115 times globally. With that, I want to thank you for your attention today. I'm going to take questions at this point for just a couple minutes if anybody wants to ask a question for the good of the whole. And then when we do break, I'll stick around if anybody wants any one-on-one time to ask questions.